So the first thing that you want to do when you're simplifying a coefficient, which is a number, is you want to type it into your calculator. And in your calculator, there's a button that you're going to hit. It's Math 5, right? So in my calculator here, I'm hitting Math 5, and then this will come up for most of you. You want to make sure that the number on the outside is that little number. For some of you, it might default as like ANS, answer. Go back and like hit clear for that so that you can type a number there. You don't want it to say answer. For this specific problem, I want that outside number to be a 5 and the inside number to be a 243. Right, so that it looks exactly like it does on your paper. And then I'm going to hit enter. If you get a whole number, then that's just your answer. If you get a decimal, you have to keep going. So the fact that this is just a 3 means that the answer to this problem is 3. You don't have to do anything else. Just Math 5. All right, I'm going to do that same thing for the next one. I'm going to do the 4th root of 1875. So I'm going to Math 5. If it says ANS out there, you want to just clear that out so that it's a 4. If you've got a decimal, you have to do more, okay? We want to work on simplifying this. So at this point, we're going to go to the y equals screen, and we're going to take whatever number's inside of the root and divide it by x. And what I'm looking to do is compare the numbers in y1, which is this blue column, to the numbers on this list. Because this is a 4th root, I want to look at the x to the 4th column. So I'm looking for a 1. No, we're skipping that one. 16, 81, 256, 625, 1296, 2401, 4096. One of those numbers. Does anybody see that in blue? Any of those numbers in blue on this screen? Numbers in x to the 4th, also in blue. $625. So I'm going to use the 625 and the number next to it, which is 3. Okay, so I went to my y equals screen, and I did an 1875 divided by x, and I'm looking at my x to the 4th numbers, 16, 81, 256, 625. This is the number I saw, okay? So next to each other, I'm going to write 625, and then the number next to 625, which was 3. Once you get to that point, you go back to your calculator and you math 5. Or for some of you, if you don't want to use your calculator, you can use this. Go to the x to the 4th column, put your finger on the 625, and then slide your finger over. You can see what x equals that way. It's 5. Or you can type math 5 and see that this becomes a whole number, and this stays a decimal. And so my answer is this 5 4th root of 3. Now, if you want to check your answer for this, you can do it in the home screen of your calculator. You see what the 4th root of 1875 is. You're going to do 5. You can't just type the 4th root of 3 right in right away. You have to hit the time symbol to separate them. And then I can do my math 5. And you can see that those decimals match. If you don't do this times, you'll have a 54 out here. It just links those two numbers together. So you have to do something to separate them before you check it. But you can check it in your calculator. All right? So that's how we work with what's called coefficients, regular numbers. When it comes to variables, you're just doing division. Inside divided by outside. So the inside number divided by the outside number. When there's no outside number there, then we write 2. So this is a square root. Square roots, you don't necessarily have to see the number. So I'm going to do x, because I can't forget the x. X is in my answer, to the power of my inside number divided by my outside number. And if that works out really nicely, then that's all I have to do. This would be x to the power of 22. I did show you how to check this one in your calculator. So you can't check it in the home screen, but you can check it in the y equals screen. So I can do the square root of x to the 44 in y1 and x to the power of 22 in y2. And I can compare the tables of those things. I see that the tables match for everything, so just a way to check my work. Now for this one, I can't do inside divided by outside. Because when I do that, I get a decimal, right? So no decimals in any of these answers. So what I have to think about are multiples of 3. So multiples of 3. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45. I'm going to stop at 48 because 48 is bigger. So you want to list those multiples out or think about those multiples up until you get higher than that exponent. So looking at these multiples, I'm going to pick the highest one, which is 45. So I'm going to split this up into 45 and 2. And the reason that that has to be a 2 is I need those two things to add together to be 47. So this still creates that 47. But here I can do inside 45 divided by outside 3 and get a perfect whole number. So that simplifies. The root goes away. When the inside number 2 is smaller than the outside number 3, you leave it. So I keep that part the same. This is the final answer for this one. All right, so now we've seen, or refresh your memory on how to do regular numbers, and now refresh your memory on how to do exponents. So then the next few examples bring those two things, those two concepts together. All right, so when you're doing a problem like this one, you want to separate the idea of this from this, because how I do that first number is not the same way as how I do the second number. So I've got 7th root of 4374. And that's a coefficient, so the first thing I'm going to do is math 5 it. Was that the number 4374? 7, so I get a decimal. When you get a decimal, y equals screen. I'm going to do 4374 divided by x. And what I'm looking for is a perfect 7. So 128 or 2187. I see the 2187 right away. 128 is not quite there yet. So I'm going to use 2187 and 2. And then I'm going to check each of them. So you can do that using your calculator, or you can do that using your blue paper. You can see one simplifies to something that looks nicer, the other one simplifies to something that doesn't look nicer. So I'm going to change the 2187 to a 3, but I'm going to keep the 7th root 2, because it's easier to write 7 root 2 than all those decimals. So this part becomes 3, 7 root 2. For this part, I can do inside divided by outside, and it works out really nicely to x to the 4th. 28 divided by 7 is x to the 4th. My final step here is going to be just to do some rearranging. So I'm going to put these two things next to each other, and I'm going to have this go after. So my final answer is 3x to the 4th, 7th root of 2. I didn't change any values there, just reordered the numbers. You okay with that one? All right, when I'm looking at this next one, the 6th root of 729 and the 6th root of x to the 53. So I'm going to math 5, the 6th root of 729. That works out nicely. So I'm going to change this to a 3. Inside divided by outside here does not work nicely. When I do 53 divided by 6, I get a decimal. So instead, I'm going to list out the multiples of 6 until I get up to 53. All right, so we've got 6, and you don't have to write them out. 24 times 5 is 30, times 6 is 36, 48, 54 goes a little too high, right? So using those multiples of 6, I'm going to go with this 48. So I'll do 6th root of x to the 48. What would my other x be? What would the exponent on the second x be? 5, right? I need them to add together to be 53. 48 plus 5 is 53. Inside divided by outside gives me an 8. When the inside number is smaller than the outside number, leave it alone. And then I'm just going to write this kind of all next to each other. So it would be 3x to the 8th, 6th root of x to the 5th. We okay so far? All right, so you guys are going to save me some time on this next one. I am guessing that this is a decimal. So did anybody put this in their y equals screen and come up with a perfect 4 that goes into 1536? 256, and what was next to it? All right, so we're splitting this up into 256 and 6. And rather than use my calculator, I'm just going to go to the 256 and see that that reduces to a 4. So it looks like I've got 4, 4th root of 6. That takes care of that part. Okay, and then let's think about multiples of 4 without listing them. What's the highest multiple of 4 below 45? 44. So we'll do 44 and 1. Inside 44 divided by outside 4 gives me 11. When the inside number is smaller than the outside number, then just leave it. And if you reorder this, the 4 in the front and the x to the 11th in the front, and then under my root would be a 6x. Okay with that one? All right, last one. I'm going to ignore this 10x to the 4th at first. I'm just going to work with the 5th root of 1701 and the 5th root of x to the 28. So I'm looking for something that is a perfect 5 that goes into 1701. So what do we got? 243. So 243, and next to the 243 is a 7. And the 5th root of 243 is 3. So that takes care of the 1701. What number did you use for the exponent of 28? Like, what did we split this up into? What's the highest multiple of 5 under 28? 25, so we do 25 and 3. 25 divided by 5 is 5. Inside is smaller than outside, keep it the same. So here's what we get at this point. We get 3x to the 5th, 5th root of 7x to the 3rd. That's no different than the previous problem. Then what we need to do is bring this 10x to the 4th next to it. And at this point, we use what's called the multiplication property of exponents. And that says that we multiply the coefficients. So I'm going to do 10 times 3. Keep the base the same and add like exponents. So I'll do 4 plus 5. And then that root just stays the same. This would be the final answer for this one. All right, hopefully That refreshes your memory because we're actually going to move on today. I just wanted to make sure you remembered how to do that stuff. We'll still be doing this stuff as we do the new stuff. But for today, you're going to need your toolkits if you don't have them out already. And we're going to start on page 3. Today you're going to learn how to go from what's called exponential form to what's called radical form. And then you'll simplify the roots. Just like we did on the warm-up. So what you have to remember is inside over outside. I've been saying that anyway, okay? So here's what it means in terms of exponents. This is called exponential form. The reason it's called exponential form is there are exponents on the variables, right? That's exponential. Radical form is when you have a root. So what you're learning today is how to take an exponent and write it as a root. What you need to know is if your exponent is a fraction, then it can be written as a root. If your exponent is a whole number, it cannot be written as a root. X to the third does not have a radical form. X to the 1/3 does. Does that make sense? So if it's a whole number, just leave it alone. There's no root for that. But if your exponent is a fraction, you can write it, okay? So inside divided by outside. So what that looks like in radical form, your outside number goes to the outside. So your denominator number becomes what type of root you're looking at. And then the x to the inside is the exponent inside, right? So inside goes inside, outside stays outside. Numerator goes inside, denominator stays outside. This only works with exponents that are fractions. I could make this a fraction, but there is no such thing as a first root. I can't write this as a radical, okay? So roots only happen, radical form only happens if your exponent is a fraction, okay? You can't turn a whole number into a fraction in this case. So if I have 25 to the 1/2, the exponent on that is a fraction. 1/2 is a fraction. If your exponent is a fraction, then you can write it as a root. The numerator of the fraction is my inside number, and the denominator is my outside number. So my outside number is going to be a 2, meaning that this is a square root. The inside will keep the 25 as the base, and the numerator becomes the exponent on the inside. What's 25 to the first power? 25. 25 one time is just 25. So I can also write this as the square root of 25. At this point, I would type math 5 into my calculator, and I'd put a 2 on the outside and a 25 on the inside, and I'd hit enter and see if I get a whole number. If I get a decimal, then I'm going to have to go to the y equals screen. And most of you probably already knew what this was going to be, but just in case, I'm typing it in. I get a whole number. And so, ultimately, the answer to this one is just 5. Sorry. All right, let's look at the next one. I have a problem in what's called exponential form because I'm looking at exponents. That specific exponent is a fraction. If your exponent is a fraction, that means that you have a root. With this root, the outside number is the denominator number. So this is another square root. The inside number is the numerator. So I'll keep the 15, the base, on the inside, and I will give it an exponent of 3. I'm going to evaluate 15 to the third power, right? So 15 to the third power is not 45. 15 to the third power looks like this, or you could do 15 times 15 times 15. All right, so I'm going to change that 15 to the third power to a 3,375. Everybody okay with what I'm doing so far? All right, so I'm going to math 5 this, the square root of 3,375. And I get a decimal. So from here, I'm going to go to the y equal screen. And what I'm looking for is a perfect square. So 4, 9, 16, 25, 36, 49, 64, and so on. None of the ones on my list are even on this screen yet. So I'm going to go down. Let's say 225 is my perfect square. And next to 225 is a 15. So I'm going to split this up into 225 and 15. Just like you did on the warm-up number 2. Right? We y equaled, we split it up. And then I'm going to type each of these into math 5. $225 and 15. You can see one works out nicely and one doesn't. Just want to show you that these two things are the same. So 15 to the power of 3 over 2. 15 times the square root of 15. Two different forms, but I get the same decimal. So I have exponential form when I have an exponent, and radical form when I have a root. They're equivalent forms. I'm just writing them in different ways. You can see they're equivalent because the decimals match. All right, for C, we've got 18 to the power of 2/3. The fact that there's a fraction there means that I can write it as a root. My outside number is my denominator, so I'm working with a third root here. What would go on the inside? 18 to the power of 2. Right? And we're actually going to evaluate what that is. So this is 18 to the power of 2, or 18 times 18. It's not 36. You're not multiplying it by 2. So that's a 324. We're looking at the third root of 324. At this point, now I just want to see, can I simplify? So that's called radical form. There's a root there. Once I have radical form, I want to see if I can simplify radical form by seeing if this reduces at all. So I'm going to math 5. The third root, was it 324? Okay. No. So then I'm going to go here, 324 divided by x. And what I'm looking for is a perfect 3. I think 81 is one, right? No. Let's see. We have one up there. 324, 162. I don't think I see one. 27? 27 and 12? All right, so we got the third root of 27 and the third root of 12. The third root of 27 is 3. The third root of 12 is not 4, okay? That only happens if this was like x to the 12th. We could call it x to the 4th. You're not dividing inside by outside for regular numbers. I'm just going to keep this as the third root of 12. (18 to the 2/3 is called exponential form. 3 times the third root of 12 is called simplified radical form. We had a root and we simplified it. They match. They are the same. They are just in two different forms. Exponential, radical. Once you get it to radical form, you still need to see if it reduces like the stuff we did before break. So we're continuing to do that stuff. We're just adding to it. You probably guessed what's next. We can do that same thing even if variables are involved. Oh, all right, so you guys are going to try these two. See how far you can get. I'm going to put some practice up.
Doing X to like whatever number it was, and they were just showing it on the
Oh, absolutely, yeah. Instead of using the sheet, yeah.
Thank you.
Yep. All right, so can someone tell me the initial step? Like how to get this to here? What number goes on the outside? Which is 4 in this case. The inside, the 2401 stays to the power of 1. What is 2401 to the power of 1? Still stays the same, right? All right, so from here I would math 5 this. Does it work out nicely? What is it?
7.
All right, done. This is called exponential form. This is called radical form. This is just called a regular number, okay? I don't call that radical form because there's no root in it, right? So the 7th root of 2401 is called radical form. The 7 is just your answer, okay? There's no special form to that. It's not exponential because there's no exponents. It's not radical because there's no roots. All right, so for this one, I'm going to have the 5th root of 16 to the power of 3. What is 16 to the power of 3?
4,000.
What is it? 4,096? I'm going to assume, because it's the second example, you probably had to go to your y equals screen. All right, so what perfect 5 did we get? And what was next to it? All right. And what is the 5th root of 1024? So 4 5th root of 4. Exponential form is 16 to the 3/5. Simplified radical form is 4 5th root of 4. You okay with that? All right, so we can do the same thing with variables, okay? The only thing that's different is the way that you simplify variables is not the same way that you simplify roots. You're not going to go to your y equals screen for a variable, but the inside-outside thing still applies. So if I have x to the 3/5, that's called exponential form. If I want to write that in radical form, because the exponent is a fraction, I can write it as a root. The outside number is the denominator. The inside number is the top number, the numerator of your fraction. Now at this point, if you wanted to break this down, you would think of multiples of 5, the outside number. 5, 10, 15, 20, 25, 30. In this case, none of those numbers are bigger than or smaller than 3. When your inside number is smaller than your outside number, you're done. Okay, there's nothing more that I can do with this one. I can't simplify it any more than it already is. So my exponential form is x to the 3/5. My radical form is 5th root of x to the 3rd. You can still check these, okay? You just can't do it in the home screen of your calculator. You can do it here though. X to the 3/5. And then I can math 5, the 5th root of x to the 3rd. So exponential form is in y1, radical form is in y2, and you'll see that those decimals are consistent in the y1 and the y2. Right? Just because they look different, they're still the same answer. They're still the same variable. For the second one, it's a fraction. If you have an exponent that's a fraction, then you have a root. Okay? The outside number is the denominator number. Don't forget to write the x. It's part of the problem. It doesn't go away. I can simplify this one though, because if I'm thinking of multiples of 3, 3, 6, 9, 12, so on, I want to make sure that I'm picking one below 5. So I'll do the 3rd root of x to the 3rd, and what would my other exponent be? 2. Remember, it still needs to add to 5. That value of 5 still needs to be here. Inside divided by outside, right? So 3 divided by 3. This becomes an x to the 1st. And you don't have to write the 1. This is called exponential form. This is called simplified radical form because there's a root, but we also did the process of simplifying. We okay so far? All right, so in this next one, you can see there's 2 different fractions. So I'm going to write 2 different roots. I'm going to write a root for the first part and a root for the second part. Both denominators are 4 though. So both outside numbers are 4. But my inside for the first will be 162 to the 1st versus the second will be x to the 9th. The way that I handle that 162 is not the same way that I handle that x to the 9th. So 162 to the 1st is still just 162. I'm going to math 5 that. but it's a decimal. So I'm gonna go to my y equals screen and I'm gonna do 162 divided by x. And I'm looking for a perfect 4. 81. And next to it was a 2. Instead of going to my calculator, I'm going to do my 81 this way. So I'm going to the 81, and I go over to see that that reduces to a 3. So this is 3, 4th root of 2. That takes care of that part of the problem. Now, as for the x to the 9th, I'm thinking about multiples of 4, 8, 12. I'm going to use the 8. Okay, I want to pick a number below 9. So I'll do x to the 8th and x to the 1. So I'm still keeping that value of the 9. And then inside exponent 8 divided by outside exponent 4, as it becomes inside over outside, this becomes a 2. X to the 1. The last thing I'm going to do here is just reorder this. So I'm going to take these and then these. I can only write those two things in pink together because they're both 4th roots. If one was a 3rd root and one was a 4th root, I'd have to keep them separate. Does that make sense? All right, so I'm going to do 3x squared 4th root of 2x. I'm going to skip the last one. It's pretty much one more of the same. Are we okay with that? All right, so skip it. All right, so you guys try this one. It looks like more, but you're just doing 3 different roots. All right, so try this last one. And for your class, we're going to end here. It's a special event scheduled today. The seniors have a meeting during bonus block. So you'll have an hour-long bonus block today. So we're out of here at 32. So I'm thinking, give you a few minutes, do this, and then we'll go over the answer. All right. Your first and second blocks are affected by this, I believe.
The rest are about the same.
All right, talk to me about 512. Anybody find a number that goes into 512?
27.
And what was next to the 27?
60.
Wait, 27 isn't a perfect 5 though. You say 27?
I mean 32, sorry.
Alright, 32. And what was next to the 32?
60.
Okay. Alright, and the 32 reduced to
Um,
2. So 2 fifth root of 16 takes care of the coefficient part. When I write the exponent of x to the 2/5 in radical form, I get this. Can I break that up?
no.
No. Keep as is. So in my final answer, I'm still just going to have this. Can I break this one up? Which two numbers should I use? 5 and 1. Inside divided by outside, and then leave. Your final answer should just be reordered. 2y, you can write to the one, you don't have to. Fifth root of 16x squared y. Tomorrow will be a practice day on this. Tomorrow, guys, is also a weird schedule. So with me tomorrow, you'll have me for an hour and a half. Just know that I will never do more with you in a long class than I do with my other kids. So you'll have a decent amount of like free time, I call it. I'm just gonna get through the lesson tomorrow. But we will do an assembly first half and then come to our class second half. Still come here in the morning and we'll go down to the assembly together. All right?
I see.